50 does not have the gene. 11 out of 50? Unusual probability is labeled as less than 5% chance of something happening. Anybody remember what independent events are? They happen by themselves and they don't affect each other. So 2 events or more that don't affect each other. Can you tell me 2 things that don't affect each other, Noah?
The probability of rolling a die and the probability of flipping a coin.
Sure, a die and a coin. Unlike people who gamble will tell you, you can't get on a hot streak. So just because you've gotten a whole bunch of 6s on a dice doesn't mean that you're going to keep on getting 6s. How'd your lottery ticket end up, Nathan?
Oh, wait.
Oh, did you win something?
Maybe I'll get another one.
Oh, I see. I thought you were going to tell me that the other day some of the statistics boys and drama boys went out and bought some lottery tickets, and they did really well, Georgia. Right?
They got a 0.
Oh, yeah?
Gustavo got one.
They got something at
Wait,
least.
this time?
I think so. That's what he said.
Really?
I'll have to ask him though.
Oh, we'll have to make sure.
It's
How much you guys
One
gonna
out of
invest
3.
into that?
I know, right?
Good to do a Mr. Beast chat.
I'm telling you, you could just hand me your money, and I could also tell you that you don't win, and then somebody gets your money that you like.
but it's
But otherwise, you're just feeding a corporation. And I'll tell you, they're really a great corporation. You know who really should invest in the lottery? People who own the lottery, because they're doing great. They're doing like super good. Like, it is not like a gamble. Like, they're like, are we going to make money today? Yes, we are. You know, like, it's just always yes. Even if somebody wins the lottery, they're like, guess what? We still made money. Sorry, I'm upset about it. Okay. Dependent. Huh?
Make your own lottery ticket.
Sure.
They could just
Nussbaum lottery.
That's right. I'll be like, Nussbaum lottery, and I'll only make 1 ticket, and I'll give it to myself, and then I'll win. Dependent events. What are dependent events?
Events that do we
2 events that do affect each other. Okay. For example, probability of a thunderstorm. And a tree going down in your yard. For example, if I said, what's the chances of on June 30th this year a large tree falling in your yard? Assuming you have a large tree in your yard. And you'd be like, I don't know, really slim. And I'd say, oh, okay. Also, there's a huge thunderstorm that day and almost a tornado. What are the chances that a huge tree goes down in your yard? And you'd be like, ooh, a lot higher, right? Because they're definitely dependent on each other. If I said, if I give you one thing, then the other one is more likely to happen. Last page. All right, talk to your partner. For example 9, please. Independent or dependent? Talk to each other. Out loud, group of 3, come on.
Yeah.
She's not gonna notice, there's 5 of us in the class. Surely if she only hears Noah's voice, she's never gonna figure it out.
Yeah,
Yeah.
so B is the example above. So
Yeah.
If you do over 85, probably.
Yes.
Yeah. Like the whole time.
Hey, I haven't yet.
Do you go 85?
Yeah.
Alright.
This is a very boring way to learn probability, Georgia, but I will tell you that we did play a lot of games in this chapter. It was fun.
Can we just tell her everything was fun?
It used to be.
It used to be fun.
It used to be fun back when we had fun. We will have fun again, but not yet. Gotta get through this week first. Then we'll have fun. Well, there's a big difference between having a skinny and 2.5 months to get through 3 chapters and 2 weeks in a block, so. All right, do you guys say this one was dependent? This one's independent? And this one's dependent? Okay.
We even talked about it and everything. It's
Wow,
crazy.
out loud, like with words? Ooh. Now, if you drive over 85 miles per hour, are you guaranteed to get into a car accident?
No.
No, in fact, some people are really great at driving over 85 miles per hour. But I will tell you that if I said to you, what are your chances of getting into a car accident today? And you took a guess. And then I said, what are your chances of getting into a car accident given that you're in a car that's driving over 85 miles per hour? I bet you that would be higher than. Doesn't mean that one's guaranteed to lead to the other. It just means that it changes the probability. Okay. If it is a multiplication scenario, that would be the word and. And means multiply when it comes to probability. So if it's the probability of A and B, it's the probability of A times the probability of B, given that A already happened. For example, number 10. If 2 cards are selected without replacing the first card from the standard deck of 52 playing cards, find the probability of selecting a king and then selecting a queen. All right, so we got 2 things happening. We're going to multiply them. What's the probability of first selecting a king, Natalie?
4 out of 52.
Nice, 4 out of 52. I threw away the king. What's my probability of selecting a queen next? Nathan?
4 out of 51.
4 out of 51. How do you multiply fractions?
Multiply the reciprocal.
Nope, that's how you divide fractions.
Oh, yeah. You said multiply. Yep.
What do you guys do? Did you say calculate? What were you saying?
Straight across.
Yep, just multiply across. When you are on the AP test, they will accept the following things. They will not accept this one. Do you know why?
It's not simplified.
You either need to simplify your fraction as far as you can, or you can write it out as a decimal as long as you go to 4 decimal places, so 0.060, which is approximate, or you could do a percentage, so you could say 0.6%. Next one, a coin is tossed and a die is rolled. Find the probability of tossing a head and then rolling a 6. What's the probability of getting a heads?
Half.
1/2. And what's the probability of rolling a 6?
1/6.
1/6. Does one affect the other? No. The only thing that changes when one affects the other is, see how this one, like the bottom number changed? Because one affected the other. This one you just multiply them, so it's 1/12. All right, I'm going to do the last one with you. Example 11. For rotator cuff surgery, the probability that the surgery is successful is 90%. Find the probability that 3 rotator cuff surgeries are successful in a row.